Hey everyone, have you ever just stopped and wondered, what is all this stuff around us actually made of? I mean, everything, from the phone in your hand to the very air you're breathing. Well, today, we're going to go on a little scientific quest to figure that out, to find the fundamental building blocks of our world. So, let's get right into it. No, really, take a second. Look around. The device you're watching this on, maybe the chair you're sitting in, the coffee cup on your desk. What is all that stuff at its core? What's the one thing that connects all of it? The world is just packed with an incredible variety of things, right? Trees, flowers, the sun, the breeze. To even begin to make sense of it all, scientists had to start classifying things. And what they figured out is pretty cool. It turns out that almost everything we see and interact with can be sorted into just three main groups. They call them the states of matter. And here they are, the big three: solid, liquid, and gas. Yep, those are the primary physical states of this thing we call matter. And it's amazing when you think about it. From a giant mountain, to the water in a glass, to the wind itself. Pretty much everything fits neatly into one of those three boxes. All right, so let's put on our imaginary lab coats for a minute. Time for our first investigation. We're going to start with a test for mass. Now, mass is just a fancy word for how much stuff is packed into an object. We're going to find out if these different states, solid, liquid, gas, actually have any substance to them. Okay, let's start with the easy one, solids. This is kind of intuitive, right? You pick up a book, you pick up your phone, you can feel its weight, its heft. It definitely seems like it has mass, but hey, we're scientists here. Let's prove it. And boom, here's our proof. It's a simple activity, really. You just take a solid object, like this piece of wood, and pop it on a balance. And look at that, the numbers on the scale change. That measurement tells us its weight, and weight is the evidence of mass. So check, solids definitely have mass. So, finding number one for our investigation is crystal clear. Every single solid object, doesn't matter if it's a tiny speck of dust or a massive skyscraper, it has mass. Case closed. On to the next one. Okay, that was pretty straightforward. But what about liquids? Things that flow and spill, like water or juice. Do they have mass in the same way a block of wood does? Well, let's check the evidence. The experiment here is super simple. First, you weigh an empty beaker. Then you pour in some liquid and weigh it again. And what happens? The reading on the balance goes up. That extra weight, well, that's the mass of the liquid. So, yep, liquids have mass. All right, now for the real head scratcher. Gases. Think about the air all around us. We can't see it. We can wave our hands right through it. It feels like nothing. So it has to be weightless, right? It seems so obvious. But check this out. This experiment is just brilliant because it shows us the surprising truth. You take a volleyball, all pumped up with air, and you weigh it. Then you let all the air hiss out and weigh it again. And guess what? The inflated ball is actually heavier. That tiny, tiny difference in weight, that's the mass of the air that was crammed inside. So there you have it, a genuine surprise for a lot of people. Even invisible gases have mass. It's not much, for sure, but it is definitely there. So that completes the first part of our investigation. Solids, liquids, and gases, they all have mass. Okay, let's move on to investigation part 2, the test of space. We know all this stuff has substance, it has mass, but does it actually take up room? In other words, does it occupy space? This is such a classic experiment, you might have even done it yourself. You take what looks like an empty bottle, turn it upside down, and try to shove it into a bucket of water. But notice what happens. The water just can't get in. Something is already in there, pushing back. And what is that something? It's air. The bottle wasn't empty at all. It was completely full of air. And that air, a gas, is taking up all the space inside, physically blocking the water from entering. So this is perfect proof that gases occupy space. And this leads us to a really huge conclusion. We have just proven that whether something is a solid, a liquid, or a gas, it has two fundamental things in common. It has mass, and it takes up space. Honestly, this is the starting point for understanding pretty much everything in the physical world. We are making some great progress here. So for our third and final test, let's look at shape. This is where things get really interesting, because this is where we're going to see the key differences that really define what makes a solid and a liquid a liquid. And this side-by-side just shows it all perfectly. On the left, you've got solid objects, like a coin or a die. They have their own fixed, definite shape.
You put them on a table, they stay that shape. But a liquid, like the water on the right, totally different story. It has no shape of its own. It just flows to take the shape of whatever container you pour it into.
And this table, this is the big aha moment where it all just clicks into place. Just look at the pattern here. A solid, it's rigid. It has a definite shape and a definite volume. A liquid, well, it gives up its definite shape, but it keeps its definite volume. And a gas, it gives up both. It has no definite shape or volume. It just expands to fill whatever container it's in. These simple rules are literally what make our physical world work the way it does.
But these basic rules about shape and volume, they're really just the beginning. They're the foundation that leads to all the other properties we see in materials every day. Like why some things bend and other things just shatter.
I mean, just think about two different solids, for example. You've got a rubber band, right? It's elastic. You can stretch it out, and when you let go, it snaps right back to its original shape. But then you have a piece of chalk. It's brittle. If you try to bend it with the same force, it just breaks into pieces. See? Both are solids, but they have totally different properties.
Okay, so after our three-part investigation, we've looked at mass, we've looked at space, and we've looked at shape. I think we're finally ready to answer that big question we asked at the very beginning. And here it is, the big takeaway. The official scientific definition we've been building up to is actually beautifully simple. Anything that occupies space and has mass is called matter. That's it. From a gigantic star down to a single tiny atom, if it has mass and it takes up space, it's matter. And the cool part is, now you don't just know the definition, you actually understand why it's true. But that leaves us with one final, kind of mind-bending question. What about things like light or heat? They don't have any mass and they don't really take up space. So, if they aren't matter, then what are they? Well, that, my friends, is a whole other category called energy. And that is a story for another time. Thanks for joining me on this investigation.